If the ratio of two variables is constant, then the variables have a special relationship known as a direct variation.
This means that there are two variables involved in direct variation. Not three, not four, but two variables only. Now let us continue.
Direct variation is a relationship that can be represented by the function y equals kx, where k is not equal to 0.
Take note, direct variation should be in the form of y is equal to kx, and our k should not be equal to 0, because the moment that our k is equal to 0, you would have y is equal to 0. And there would be only one variable involved, and that is y. And in that case, we will only have a horizontal line, which would mean that it does not represent rather a direct variation. Let us continue.
The coefficient of x, k, is called the constant of variation.
And now let us continue to writing mathematical equations from the given mathematical statements. Let's start with number 1. So you have here A, capital letter, varies directly as S, also a capital letter. So the two quantities or two variables involved here are A and S. And you need to be careful with our variables. If it's written in capital letter, then you copy its capital letter form. If it's small letter, then you use a small letter. Now, in writing this one in its mathematical equation, just copy A. So we had here A. Varies directly, there's always a constant variation, so equals K, where this small letter K represents the constant of variation. Then just copy capital letter S. So A varies directly as S is equal to A equals KS. Now let us proceed to statement number 2. The area represented with a capital letter A of a circle varies directly as the square of the radius small letter r. So the two quantities involved are area and radius. And area is in capital letter, you write A. Then varies directly, this always equals K, the constant of variation. And take note, the square of the radius, and that is r squared. So the area A of a circle varies directly as the square of the radius r, and that is equal to A equals kr squared. And now let us proceed to statement number 3. The distance d covered by a moving object varies directly to its speed, represented with small letter v. So the variables or the quantities involved here are distance and speed, d and v respectively. So you'll write d varies directly equals k, our constant of variation, then copy small v. So the distance d covered by a moving object varies directly to its speed v is equal to d equals kv. And now let's proceed to recognizing direct variation from a given equation. And how do we recognize it? So we will have this one. To determine whether an equation represents a direct variation, solve it for y. And if the equation will be in the form of y cos kx, where k is not equal to 0, it represents a direct variation. So, again, we need to solve our equation, solve for y in terms of x, or it should be in the form of y equals kx. So, transforming all the equation in this form, y cos kx. And that equation represents a direct variation. Let's proceed to state equation number 1. 3y minus 6x equals 5. Our reference here is the equal sign. There are only two sides of our equal sign, the left and the right. On the left, we had two terms, 3y minus 6x, and on the right, we had only 5. So, we want to target y that would be left in the left side of our equal sign. So we will transpose negative 6x first on the right side together with our 5. So the result would be 3y equals 6x plus 5. Negative 6x becomes positive 6x. And take note, the numerical coefficient with our terms that is left in the left side is 3, we will use 3 as our divisor. So it's here. So 3y divided by 3, the answer is y. Copy equal sign. 6x divided by 3, we had 2x. 5 divided by 3, we have 5/3. So the transform equation now is y equals 2x plus 5/3. This is not in the form of y equals kx. So this means 3y minus 6x equals 5 does not represent a direct variation. Now let's proceed to statement number 2. 2y minus 10x equals 0. Again, there are only two sides of the equal sign, left and right. We will transpose negative 10x on the right side so that 2y will be left on the left side. So we had 2y equals 10x. Negative 10x becomes positive 10x. Every time you transpose a certain term from the left side to the other side, the sign would change. A negative term becomes positive term, or a positive term on the other side. If we transpose on the other side, it becomes a negative term. Now, the numerical coefficient with our y here is 2, so we will use 2 as our divisor. 2y divided by 2, the answer is y. Copy equal sign. 10x divided by 2 is 5x. This is now the transform equation. Y equals 5x, which is equal to y equals kx, where the k here represented by 5. So, 2y minus 10x equals 0 is an equation that represents a direct variation. Okay? How about recognizing direct variation from a given table of values of x and y? Okay. When a set of data pairs x, y vary directly, you have y divided by x, the values of y divided by corresponding value of our x, which is equal to the constant of variation, or the k, should be the same to each data pair. Okay. For the data in the table, does the y vary directly with x? If it does, we will write an equation for the direct variation. Now let us try first the first table. Okay, if it's a direct variation, we will write its equation. So we only have simple division, y divided by x. We will try the first pair. 6 divided by 4, or reduced to lowest term, we have 3 halves, or that is 1.5. We will try the second pair. So 12 divided by 8, or 3 halves. They are the same. For the third pair, 15 divided by 10, reduced to lowest term, we have 3 halves. Take note, all the results are the same. So that would mean this table represents a direct variation, and its equation is in the form of y equals 3 halves x, where 3 halves are the constant of variation, the result, the quotient, okay, as we divide y with the particular values of x. Okay, now this is a direct variation. Now let's proceed to the second table. We have the first pair, 3.2 divided by negative 2. We have negative 1.6. 2.4 divided by 1. Divided by 1, they have 2.4. They are not the same. In 1.6 divided by 4, the result is 0.4. So, the result should be the same in order for the table to become a direct variation. Okay, so since this is not a direct variation, no need for us to write its equation. Okay, now let's continue. Graphs of direct variations. The graph of a direct variation equation y equals kx is a line passing through the origin 0, 0. The constant of variation k is the equivalent slope of the line. Okay, take a look with this one. Okay, this is a line. So that would mean the graph of a direct variation should be a line. So this is a line. And it should passes through the origin 0, 0. So, and as you noticed, from left to right, the line rises, which indicates the slope of this line is positive, which is equivalent to our constant of variation k, greater than 0 since it's positive, or rises from left to right. Look at the second one. This is also a linear graph passing through the origin, 0, 0. From left going to the right, it goes down. So this means the slope of this line is negative, or our constant of variation is less than 0. Okay.